All right, welcome everybody. This is the language panel. We're going to discuss language design, talk a little bit about different blockchain DSLs, and maybe get some interesting conversation going. We're actually waiting on one more guy. It's going to be with the Viper team, so we'll come back to him whenever he gets here. But briefly, let's just go down the line and introduce your language and include something you consider unique to your programming language.
I'm Maxime. I work on the Noir language at Aztec. We are a zk DSL, but we are looking to add smart contract functionality soon. And something unique to our language, though, that differs from other zk DSLs that are out there, is we compile down to an intermediate representation to enable us to be backend agnostic and use different zk proving systems.
Hi, my name is Emily. I'm with Fuel Labs, and we build Sway. Sway is a language for blockchain, and it's inspired by Rust. So Sway, one of the unique things that it has is that it's a combination of featuring things that are safe for programming, for the users, and then also a good developer experience.
Keep the mic from the same distance from the mouth, so when you're speaking, just make sure it's as close to the mouth as possible, right? And then we won't get that feedback.
Okay. So I guess closer.
Oh.
Well, and closer, I guess.
Yeah, so Sway combines type safety and programming safety for programmers, as well as a wonderful developer experience. So one of the things that it does is it does static analysis on your code. So it checks things that might otherwise be missed, and if one of those bugs is found, it fails to compile or gives you a warning as a user. So one of those things would be checking to see if reentrancy is violated. And then it also has a wonderful developer experience. So Sway comes packaged with developer tools like a build system, a debugger, VS Code extension, and more.
Hi, everyone. I'm Todd Nowaki. I work on Move at Miston Labs and SWE. So we're kind of most recently just been kind of working on integrating Move into SWE. I've been working on Move since about 2018 back at Facebook and Diem. And I guess the sort of interesting thing about Move is, unlike a lot of other smart contract languages, we don't actually really have a notion of contract. So there's modules that can interact with resources or assets, and the data is then sort of separated from the code in that way.
Hello. I'm Hari representing Solidity here. The Solidity needs no introduction, but what's unique about Solidity is that over like multiple years, we have been very pragmatic about building the language, and somehow we made the right choices to really attain like a product market fit sort of. We have essentially defined what smart contract languages are and smart contract blockchains are today.
So, while we're still waiting on Patrick, I guess I'll just briefly fill in for him for Viper. So, the Viper language is a Pythonic smart contract language specifically targeting the EVM. It's got tons of Python-related things in its toolchain. We have ApeWorks, Brownie, Web3 things like this allow you to interact with this and keep your entire stack essentially in Python. It is almost a Python subset. There's like a few keywords, things like event logging that's special to it, but for the most part, it is Python for the EVM. So, coming back around again, what do you think is the future of smart contract DSLs? And in particular, are we going to have this future where people just have to learn tons of different languages for different applications? Or do we think that maybe we could have a handful of languages that are modular enough to compile the multiple backends?
It's funny because you said either way, we're going to have a ton of languages everyone's going to have to learn, or a handful of languages. I think the fact that you asked that question means that there will be still several languages that serve different use cases. Specifically Noir, it's designed around privacy first, and this is something that's very hard to integrate into an EVM model, but you're not necessarily going to want that for everything, and writing a contract in any of the languages that are to my right might be simpler if you don't require privacy, and I do see probably, though, there will be still a few winners, but I find it unlikely that there'll be just one or two smart contract languages that everyone interacts with.
going off the idea of modularity, something that I'm really excited for is the idea of maybe having modular backends. So something that I think about a lot is how successful and how awesome LLVM is. So LLVM is a very popular target language for a lot of languages to compile to. So like Rust, for instance, compiles to LLVM, and then LLVM will output assembly code for a bunch of different architectures like x86 or multiple different ARM architectures and so on. Like I couldn't even name all of them. And it's really benefited compiler design because it's allowed us to compose modular compilers. So this is something that we've thought about at Fuel with Sway. And Sway has a very thoughtfully designed IR that's extensible with this in mind. So right now, Sway can target the FuelVM, but we're also working on a backend for the EVM. So this backend uses the same IR as the FuelVM. And as programmers for Sway, what this would mean is the same Sway code that you're using to target the FuelVM would also target the EVM. So you could compile it with the same toolchain and just change the target. And here's some alpha for you guys. We're also working on another backend. I can't say what it is, but we're working on it. So keep that in mind.
Yeah, so I think, these points about like the sort of different use cases are really good ones. It's why like we have Rust and Go, or why you have Python or even like people still break out Bash if you're like writing a little script. Like it's really helpful when you're targeting a specific application to have a language that has the properties that sort of are guaranteeing things that you care about in that instance. I think that for smart contracts, we'll probably have sort of different use cases of like, I really care about like resource safety, or I really care about, zero knowledge proofs, and you'd want to break that out. I think one of the interesting things or challenges when we're kind of thinking about having, either shared backends or like compiling to different projects, or like taking one language and compiling it to a different platform, is that unlike a lot of other languages, you don't have this like, or in other programming environments, you don't have this sort of flexibility of, well, I'm compiling my program and running it locally as a binary. You have this like huge world of external state of the environment. And that in smart contracts, you're really programming against this environment in a way that's quite unusual compared to other languages, whether it be, the state in your smart contract, or from a move perspective, you have all these sort of objects or resources coming in as like arguments to your functions that are kind of being pulled off state. And while, we try to like mask those things and move, you still have to be thinking about like, how am I actually going to be storing this thing on the blockchain? And I think that's going to be something kind of, I know we've struggled with it a bit in terms of there was a project that tried to take Move and compile it to the EVM, and that's really difficult when the way Move thinks about global storage is maybe very different than the EVM, or at least how DM was thinking about global storage was very different than the EVM. So I think this will be an interesting thing in years to come to kind of think about like solving these sort of problems in a generalized way.
When it comes to DSLs and especially like targeting zero knowledge ecosystem, Solidity has a luxury of adoption, which means a lot of people want to compile Solidity directly to whatever VM that your blockchain is working on. I've seen a couple of different approaches here. The approach by Polygon Hermes is simply just work on EVM, don't deal with any of the high-level language. I believe the approach by Matter Labs is work with Yule, which is the intermediate language for Solidity, and then translate it into their own intermediate language, and then they can do whatever they want. A similar approach is also done by Nethermind, which transpiles Yule into Cairo. So from Solidity's perspective, we are very open to like having more features in the language or in the compiler that allows for easy translation. But I think there is a lot of room for people to experiment on high-level languages. And Solidity makes it somewhat easy to target EVM by simply targeting Yule. That's what Faye one of the other languages is doing. So yeah.
All right, cool. Hi, everybody. Sorry I'm late. My name is Patrick Collins. I had a talk other side of Denver, so just got here. But yeah, so do I see a lot of different smart contract languages? I think absolutely. I think with exactly what he was just saying, we're seeing use cases where you need to be able to break into the bytecode. You need to be able to write some high-level language that has a way better developer experience, but you need something to, when you need to just do something very, very specific. So, and we're seeing, as some of the other panelists have mentioned as well, these different blockchains that have different architectures from the ground up, right? And maybe one language that's super specific to the EVM won't work for another. So I definitely see many languages coming about. I'm curious to see, because I know a lot of projects are thinking, okay, we're going to do this one language. This language is going to be good for everything. I feel like in the software development world, in the Web 2 world, we've already seen that having one language to dominate them all doesn't ever work. So yeah, I see a lot of different languages, and I'm really hoping we focus on developer experience of these languages, such that we don't have to be savants of the language to build powerful protocols. Oh, you got a mic, nice.
Yeah. Interesting. So, kind of building on this a little bit, because I kind of want to linger on this for a minute. So, actually, one of the Viper compiler devs, his name's Big Tech Sucks, really smart guy. But I've talked to them a little bit in the past about intermediate representation and can we have something that's abstract enough that can target multiple backends and maybe allow you to write, if not a single language for every application, at least having a generalized language. So I don't know. Would you consider? I guess we'll start with Viper here. Would you consider this to be something that maybe you could compile this to different backends, and would you want to? Would it be too much work to rework and relearn architectures and deal with all those changes?
So if I can simplify the question, could we have a lower level language that, no, the other way around. Could we have one high level language that compiles to all low level languages? Is that what you're kind of saying?
Right.
I don't know, is the honest answer. I don't know. I don't know if it's, because we see that in Web 2 all the time, right? We're going to have Python be in the front end. We're going to have JavaScript, but it's meant for systems engineering. It usually ends up being really gross, takes a lot of work. I would love to see something like that work, but I think in practice it's really difficult.
Right. Yeah, and I think in some cases it is very specialized, right? Noir is specialized for zkSync, right? And Move is specialized for this resource-driven programming. But of course, everything that can be written in JavaScript will eventually be written in JavaScript. And I'm sure we'll have something like that in blockchain too, right?
All right, so this is where my Viper side is showing. I hate that mantra. I can't stand that mantra. Do I pass it now? Is that the strat?
Anybody have anything to say about that?
Sure, yeah. I would tend to agree in the same way of if you're working on a server side, you tend to want to pick a server side language that's solving your problem in a very specific way. I could see a space probably for more, think about configuration languages or other things like this that maybe, or little protocol languages, take Thrift. You have Thrift bindings in a lot of different languages. It's maybe a bad example, but I'm just trying to imagine a world where you're a very high-level declarative language for certain applications where you don't care too much about the specifics. Maybe you have one little thing you're trying to do on a certain blockchain. But I would probably tend to see that for most interesting applications that you're going to need to leverage a lot of the things that make whatever blockchain you're building on unique. And when you get into that, it's kind of back to the thing of trying to write server-side code in JavaScript that you're gonna have a bad time. And you might get it to work, right? Or you might have this other whole realm of kind of native APIs that you don't have to or FFIs that you're calling into. But when you're at this point, you're no longer writing in JavaScript, right? You're now writing some server-side language that just happens to be in JavaScript with none of the upsides that you normally get there. And then none of the upsides of having some strong statically typed language. So I think that maybe like there's a good space for maybe something like very high level, or also maybe like a language that you can take the benefit of like, well, I know how to program in something that kind of looks like this, and I can take that like skill set, maybe kind of like SQL is maybe a better example than Thrift or something, where if you go to one company, like they have their own SQL instance and they have all their special SQL functions, and you have to learn how to write SQL at that company or for that database. But you still have this like core skill that you've developed as like a SQL engineer or a SQL programmer. Maybe that's like a space for it. I'm not really sure though.
Sure, and I think for me, like looking forward in the future, 20, 30, 40, 50 years, I personally don't know what applications people are going to be building on blockchain and beyond. I don't know what the use cases are going to be and what languages people are going to be favoring. And so I think something that I keep in mind always is like, right now the technology that we're using, it's kind of like turtles all the way down, right? So, we're using languages that compile to another language that compiles to another language that, eventually gets down to ones and zeros. And at some point, ones and zeros were the technology breaking thing. And so I'm excited for the future of what's to come in terms of language design. And I even think the languages that are up here right now, or domain-specific languages that are out there, could become IR targets in the future. For example, I know Rust is a very excellent IR target for domain-specific languages. So you could write a DSL and actually target Rust, and then you'll get the same benefits of using LLVM without having to target LLVM directly. So, that's kind of a non-answer, but I think it's kind of like we don't know. And so I'm sure there will be lots of IRs now and then, but the ones that people use most frequently will get the most support. And eventually a graph of compatibility will form. And I think the best that we can do is try to make that the most well-connected and the most enhanced and least brittle graph we can.
Right.
I don't entirely remember the question, but you said something that I kind of wanted to also reiterate. I think a lot of times we are in a very different execution and storage environment than classic Web 2 languages. And for example, specifically with Noir, we do have an IR ourselves that we call the ACIR, it's Abstract Circuit IR, and we have our own VM for that IR. And this IR can target many different proving systems, but this is only really the execution side of things. What Aztec is working towards now is creating an execution and a storage network. And we're going to have to most likely embed our VM and our current IR and extend that. I don't know. I imagine that the kind of challenges you saw with moving Move to the EVM would happen if someone tried to make this Noir environment we're making with an entirely new network. I know for a fact we will never target the EVM. It's just never going to happen. It would have to be an entirely new environment. So it's just something. The IR is very beneficial, but it still has its limitations.
Right. And I want to push back a little bit on kind of like the details of like the architecture that we're targeting, right? Because right now, it does seem like FuelVM, EVM, Aztec's VM, like these are all like different architectures, and it's like really complicated to try and compile with this, right? And it makes sense now to have a specialized language because it needs to be efficient, right? These are more or less resource-constrained environments, right? But like that might not always be the case, right? So I mean, in the same way that like if you write Rust code, like there's small considerations, like if you want to compile to WASM, right? But like the differences between x86, ARM, and WASM are not drastic enough that it's like, okay, we have to rewrite this and write everything in this like one specialized language. Now we'll always have it, right? But I mean, what do you think?
Well, so I kind of want to say something that I think will summarize a point that we're all kind of trying to make. Languages are a tool, like a hammer, like a shovel, like a rake. If you have a hammer, everything looks like a nail. And it's great for doing what it's supposed to do. It's great for nailing nails. But if you have a hammer and you need to pave your driveway, and you're like, well, I already have this hammer, I'm going to use this hammer to pave the driveway, I don't think that's the best choice. So I think it's the same thing for languages. If you have a language and you try to just shoo it into everything that you do, when it's designed to do this very specific thing, you're going to get poor results, or it's going to take way more work than it should.
So you would consider the different backends to be separated enough that we shouldn't treat them all like nails?
I think so. I mean, right, I just made that point, and I'm like, oh, maybe. I think it's very difficult depending on how different these backends are. So I think the answer to everything in life is it depends. And I think it depends in a real way.
I actually agree with Aztec here. I think one of the reasons behind why Solidarity's success is we have been very close to EVM, and all the design decisions we made were really targeting EVM. Whereas there are other people who say, okay, why don't we just build a Solidity to LLVM codegen and then LLVM to EVM codegen. There has been multiple teams trying to attempt this, and they never really had any success out of it. So I think the underlying issue is that LLVM was never really designed to target stack machines. There are workarounds and hacks for this, but it's not what you want to do. So I do think Aztec's approach of if you have a completely different computational environment like zk circuits, then you probably need a corresponding DSL or an IR. I think that's the way to do it.
Right. Cool. So moving on to a semi-related topic, zk circuits are all the rage right now. Great for scalability, privacy, all these fun things. So in what way could your language maybe apply to building these zk circuits?
I could go first, but I think a lot of people have been trying to translate Solidity into zk circuits. There's a transpiler for Cairo, transpiler sort of for Matter Labs implementation of their zkVM. Some zkVM implementation just work on EVM itself, so the translation doesn't really matter. But apparently it's really hard to do that. But people still manage to do it. But yeah, I think we would be open to improving the compiler to better support zk. But yeah, feel free to talk with us.
Sure. So I've mentioned that one of the backend targets that the Sway compiler is targeting is the EVM. And when that is completed, support for zk EVM will fall out of that. So I think that's probably the most straightforward answer from the Sway perspective. But I think something that we've been thinking about is Sway is designed first and foremost for UTXO-based architecture because that's what the FuelVM is based off of. So we're thinking about particular harmonies that might exist between UTXO-based zkVMs and the inherent design of Sway and the IR, considering that it was originally designed for a UTXO-based target.
I was just going to say that I don't know enough about zero-knowledge circuits to have much of an opinion, but I'll say something anyway. I guess to me, my worry is that I think it kind of goes. Absolutely loved this tool analogy of paving your driveway with a hammer, and this is my kind of gut reaction when I hear someone there's been projects that are oh, I want to take Move and I want to compile it to some zero-knowledge circuit. I'm like, do you? I don't really know if you want to. It's a language built for interacting with storage in a very specific way and for building up abstractions around assets in a very specific way, and that's what it's good at. I would probably say that I'd go probably look at Noir or something first, who's been thinking about this problem a lot more than we have, and they will probably be a better place to start than to try to take some other existing language and compile it to zk circuits.
So this is where I think we have a practical example of your question here. If you have a hammer, everything looks like a nail. But maybe in this case, we're saying hey, you just need to tweak to have a zk EVM. You can still use the hammer, and now you just change the handle or something like that, or maybe change the way the head looks, or just do some slight modification, and then you can keep using the same tool, and you're still hammering, maybe it's a different type of nail, right? And that's why I said to your question that it depends, right? Because if they're similar enough that it's, all right, cool, I can still use this hammer, these are different types of nails, it still works pretty much the same, it's fine. It's when you get to that, okay, I got to pave the road now, where you might want to think of something else. But if the nails are similar enough, and hopefully you're all sticking with this analogy here, if the nails are similar enough, yeah, sure, ship it.
Just to tag on to kind of what everyone's been saying, there's two approaches basically. You can target an existing VM, and we've seen lots of projects currently working on that, and that's the zk VMs we've been seeing everywhere. Or you can write your own VM, write your own DSL to target that VM, and that's the approach Noir is taking. And it's largely because we're going back to this hammer analogy. The constraints and the environments in which you're writing zk circuits, I think, are drastically different than what we're familiar with in classic smart contracts. That hammer that you're changing, it might be slightly different, the nail's slightly different, but it's still going to be a little bit harder, or there's going to be some overhead that's going to make it a little harder to pull the nail out of the board. While if you have a specialized something that actually serves that purpose, it should be more performant, more accurate to what you're trying to do. Perhaps this is diving into the alt VM, EVM discussion later, but I think it all ties together.
Awesome. So it sounds like we have two Rust-like DSLs that could, in theory, compile to zk circuits. So how do you think the two languages stack up? I guess, Emily, if you'd like to go first, I'd love to hear, what do you think are some of the advantages of using Sway in particular in a zk environment? Maybe something that stands out about Sway that would be good for this, and then. Oh, sure. Okay, so I think for me, one of the things that there's many things that I like about Sway. I'm a little biased. So I think it's a very excellent experience writing it. It's inspired by Rust, as I mentioned at the beginning, so it feels similar to Rust as you're writing it, and you have a lot of access to the features that you would have access to when you're writing with Rust. So these would be like traits, generic types, structs, enums, match expressions, etc. But in addition, there's blockchain-specific data structures like first-class storage, types that are specialized for interacting with storage, optimized for storage, and more. So all of those combined allow the Sway compiler to do extra blockchain-specific static analysis and then also give you back error messages that help you program and help you write your code. So when I'm writing Sway code, for instance, if I forget to write an exhaustive match expression, which happens more often than I would like to admit, the Sway compiler will remind me that I have not written an exhaustive match expression. And for those of you that are familiar with Rust, it's a very similar experience to working with the Rust compiler. Another thing is if you've written a code that violates the CEI pattern, the Sway compiler will warn you of that, and the compilation step will fail. So you're actually not allowed to deploy that code if the Sway compiler detects reentrancy. So I think that's kind of outside the bounds of the question. It's not in particular related to zk circuits, but in general, I think that kind of encapsulates the whole experience of working with Sway, is that it feels like you're working with the compiler and you're working with Sway. It's helping you program. So, maybe that's again, a non-answer in that it's helping you write your zk circuit code. So I think, yeah.
I actually think what you said still, because we obviously target different execution environments, it still carries over to some of what Noir does. For example, as we don't have full smart contract functionality yet, we're not checking for reentrancy, but we do check for certain things on the zk side. That's similar to what Sway is doing with blockchain constructs. So if you cannot have under constraint circuits in Noir, or at least you can't write them. Potentially, if the compiler is incorrect, that's a different story, and compiler misses it. But what we're trying to do is make it that developers can write safer code and and rely on the compiler more rather than necessarily the developer. I think this is pretty similar to what we just mentioned with Sway, and yeah, I can dive a little bit more into it. I forget what was the exact wording of the question though.
Yeah, it's basically just like what kind of features really stand out about your language. In particular, things like generics and traits and.
Oh, I can go.
like
Yeah.
that.
So we recently added more high-level features such as generics. We recently added first-class functions. We don't have a full trait system, but you can mock that using structs and first-class functions. And we are looking to add more high-level features, but we also will, our compiler will also, type check, give you warnings if you're using things you're not supposed to, and we're trying to improve it to be, provide a more heavy static analysis and make it easier for the developer to catch errors before on compile, not when they're running it.
Right. Very, very cool. Actually, I think Noir is the only one that has first-class functions. So, guys, win first-class functions for like everyone else. I'd love to see it. It's a really, really cool pattern, and it's cool to see that like people are thinking about this, right? Even though it is complicated.
One of the reasons we decided to go with like first-class functions is because it was ultimately we decided building a full trait system might be more complicated than implementing first-class functions, and that was more of just a design decision that the team made.
Gotcha. Actually, this is a little bit on the spot, but I'd love to go down the row and hear like what are kind of the thoughts with having like first-class functions and for languages that don't have it, like traits and things like that in the languages. So I guess you guys already answered, but if you want to go ahead.
Okay, sure. Yeah, so I guess going off of a few things that were said here, especially like kind of re-entrancy is a big one. So, move, from like a VM standpoint, right, the moved VM is not designed to really be a sort of general purpose target in some ways. It's a strongly typed and very opinionated bytecode, and if you go look at the bytecode spec, like you might be surprised at like how high level the bytecode really is for like if you're used to reading VMs at all. Like all of the types that you generate from compilation still exist like down at the VM level, like nothing's scrubbed away or erased. And the reason we do this is that because these values can pass between the modules, and that we want to make sure, I think also is just like we want to make sure that, it's not just about making sure that in maybe a normal programming setting was what I'm trying to say is that you're fine with, okay, the compiler is going to tell me yes or it's going to tell me no because it's about my code that I'm running on my machine. But here you're taking code and you're running it on like someone else's machine, and then other people are going to be sending their money into this machine. And we want to make sure that, from a network standpoint, we don't want any code that is potentially malicious on the network. And so from that standpoint, we have this very strongly typed system. And if there's the ability to remove an entire class of problems, like we'll just make sure we have the feature or the safety rules that allow that to happen. So we don't have any re-entrancy issues in move at the execution level, and it's not just like one of a compiler safety thing. It's just like it's not possible to express it in the language. I think that looking at like first-class functions or similar things, it's very difficult to get that right without also then allowing for re-entrancy to kind of come into the picture or similar problems to come into the picture. I think that from a core standpoint in move, there's a difficulty from an asset safety kind of issue of like, you might call into some code that, steals all of your money. Maybe a different way to say this is, I'm not sure I would want to give, like a function pointer or a first class function is like, gives the ability for someone in my code to run, or like in my contract to execute arbitrary code in the middle of my contract. And I'm not sure I'd want to give someone that ability to do that. It could be maybe an interesting like design problem to like constrain it. So it's like, well, I know that these functions are only doing like pure things, like a comparison operator or adding two numbers together or something similar to that, and not really modifying the state or doing anything that you might consider malicious in that way.
Right. So actually on that, with function types and things like this, I'd actually love to hear, because Solidity has some pretty interesting stuff going on with functions, and how they can be passed around. Can you maybe explain a little bit about that?
Yeah, I mean, Solidity has function types, but I mean, we don't really recommend using function types, mainly because there are two ways to implement function types. We have two different codegens in Solidity. One of the codegens, the old codegen implements a little bit unsafe way to implement function types, in the sense that if you're trying to analyze the bytecode, there's going to be some dynamic jumps for the function calls involving function types, and this leads to bytecode that's harder to like statically analyze. If you ever wrote a tool that interfaces on EVM, a big pain point is like dynamic jumps, and we don't want to make it even more complicated. So for the new codegen, we went with a different approach, which does not use dynamic jumps. It's going to be still more or less static jumps, but this comes with an efficiency problem. It won't be as efficient as the old one, but it will generate bytecode that's much easier to analyze. So yeah, I think function types are an interesting idea, but yeah, they end up generating bytecode that's harder to analyze. Maybe we can fix that with some of the new EIPs in the EOF suite, but as of now, yeah, they generate terrible bytecode.
Interesting.
When did y'all get function types?
Sorry?
When did function types come out?
Long time ago.
Wait, now I'm like, oh, I got to learn this about Solidity.
They're a little bit weird. They're kind of odd to work with. But
Gotcha.
actually, I'd kind of like to hear your thoughts on it. I mean, will we ever have like lambdas or something in Viper?
I mean, I'm not on the core team, obviously, but that's a good question. I personally, I don't love like anonymous functions. I understand their use case, and I know. I mean, I love Python, and I know lambdas are huge in Python, and anonymous functions are huge there. I don't know. I don't love them. I feel like they syntactically, because I'm always focused on like, how can I make this, how is this language going to help me as a developer? And to me, a developer experience is really important. And if I see a line and it's got like 8 lambdas mixed in, smoshed together, I'm like, that is disgusting. I have no idea what that's doing. That's going to take me forever to read. So that's just personally why I don't love lambdas. Now at the same time, I do use them a lot because it's much quicker for me to just write one line. But code is written much fewer than it is read. So I prefer a more readable thing. I feel like lambdas don't make it that readable. But to answer the question, I don't know. I think I would err on the side of probably not, just because the whole ethos of Viper is to keep this minimalistic approach, to kind of keep this really strong developer experience, this experience where it's very easy for an auditor to go through the contract and understand right away what it's doing. And I think if you add this kind of anonymous functions that can like be really difficult to read, I don't see that. I don't see that being added and being consistent with the ethos.
Right. By the way, I just want to call out real quick. There's a Viper contributor in the audience here, and he's kind of on the lambdas. Now I will say it is useful. I do agree, but I think we've all seen this Python developers that just abuse it a little bit too much and all of that. But
I will say first-class functions are different than lambdas. Lambdas are built on first-class functions. So we have first-class functions, but we also have lambdas and closures and such, but that's built upon first-class functions. You don't have to necessarily implement anonymous functions if you add first-class functions.
Gotcha. All right. Well, I think that's actually going to be time. So thank you guys so much for coming up here. Thank you guys for listening.